Hi, I am Manipranay, studying at Sanskriti School of Engineering. I am done an internship on embedded systems on the project of washing machines using PIC 16F877A microcontroller. First of all, thank you for giving this opportunity and special thanks to Emertex Information Technologies for providing the free internship for me. And it was a great experience in automation and control, and it was I experienced more in this internship period. In this session, we will discuss about introduction, embedded systems and components, softwares used in this project, PIC controllers, embedded C, peripheral descriptions, project demonstration, sample outputs. Introduction. Washing machines are used in reduce human labor and save time. It means we can reduce the human work, and we will save the time by the automated washing machines. Many customers are attracted to this fully automated washing machines because uh, automated washing machines uh, will wash the clothes, and it will dry the clothes, and it will give the uh, dry clothes out, and it will send the messages, or it will ring the alarms when the task is completed. In this uh, in this project, we have built a sample washing machine prototype using PIC 16F877A microcontroller. First, what is embedded system? We need to know about what is embedded system for doing this project. It is a combination of both hardware and software electronic gadgets to do a specific task, which means hardware is a washing machine and software is a application, and by combining this we perform the task. In software, we can give the code or instructions to the hardware components to perform the specific task without involvement of human. Examples, we can see the examples of embedded systems many more, and some of I prepared here. Microcontrollers in household appliances like washing machines, industrial control systems in manufacturing plants, navigation systems in automobiles, and medical devices like pacemakers. Types of automated systems. Uh, in these types, we have two types based on performance and function recruitment based on microcontrollers. Based on performance and functional recruitments, again divided into four types: real time, network, mobile, standalone. Real time means it will access the data in real time and in any time, and gives the exact data which is running now. Network means it is connected to another devices with wi-fi, bluetooth, ethernet, zigbee, anything by with the anything network, it is called network. And mobile means we can carry the uh, device to anywhere. Standalone means we can keep the device in particular place with fixed place. Based on performance of microcontrollers, divided into small scale, medium scale, large scale. Small scale means which is do a specific small specific task like uh, to give the alarm when door is opened. It will give only when the door is opened, it will give the alarm. That small things. Medium scale means it is have the home like semi automated washing machines. Large scale means it is the controllers are used in industry automation, which are helped in efficiency of work. And here we can see the components of embedded systems. And CPU means we know a central processing unit. It processes the data from various devices, and it sends information and it stores the information. Memory is used to store the data. FPGA means field programmable gate arrays. A/D means unlock to digital conversions. Sensors means which it will takes the input of a physical quantity and gives the output in electrical form or electrical signals form. Actuators means it will takes the electrical signal, and it will gives the output as a physical output. You can see the user interfaces, electromechanical backups and safety, which means we can keep the backup data, and it will say by safe. In this slide we will see the PIC microcontroller about information. To build this project we use PIC 16F877A microcontroller. We can see some specifications here. It has 40 pins. It has 5 ports in total, which are called port A, port B, port C, port D, port A. In port A have 6 pins. Port B, port C, port D have 8 pins. Port E have 3 pins. It supports several communication for it supports serial communication for it has 2 pins, transmitter and receiver. Serial communication means it will give bit by bit data. It can also support SPI protocols. We have oscillator frequency range from 4 MHz to 40 MHz. We use the mainly 3 softwares here: PixSimLab, MPLab X IDE, XC8 compiler. By using with these three applications, we will build the automated washing machine. Here we can see the MPLab X IDE logo, and here MPLab XC compiler, and this is the PixSimLab simulation, and this is the PixGenius board PIC16F877A microcontroller. Embedded C. C is important for embedded systems due to its efficiency, portability, and low level access, enabling practices control over hardware and optimal resource utilization. Uh, C language is plays the role in embedded systems to link up the peripheral device to microcontroller, and it will sense the information to do the operations. Here we can see the data types, variables, many more. Here we use data types and variables for understanding different data types and variable declarations for efficiency memory usage. Pointers and memory managements, manipulating memory address and accessing hardware registers directly. And we use functions, modular programs, preprocessor directives, and we will see the code how to give in MPLab X in further slides. Here we can see the peripherals. LED, we are seeing here, we are seeing LED. LED means light emitting diode, which is used in several applications, and it works on the when the electric current passes in this LED, it will glows. It is an external device connected to microcontroller port. A port is interfaces between the controller and external peripheral. LED is commonly used in various applications as we are discussing now, and included indicators, displays, illuminations, and as components in electronic system due to their efficiency. And we use the tactile switches and digital keypad. In digital keypad, Here we can see the switches. These are called tactile switches. In a microcontroller, switches are often used as input to control the operation of their input to interact with the user, which means when we press the tactile switch, it will give the information to the user or any uh, microcontroller to access this function. As we discussed, when it is pressed it will on, and when we will release the switch and it turns off. They are typically connected to specific input pins of the microcontroller, enabling the detection of switch state changes. Here we can see the CLCD. CLCD means character liquid crystal display. Character crystal liquid display is a flat paneled display technologies that uses liquid crystals to modulate light and display images or textures. LCDs operated by modulating light through liquid crystal created by electrical signals. And here we can see the pins of LCD, and VSS means ground, VCC means plus 5 volts, which is uh, uh, positive. V means construct controller, which means which controls the brightness of this LCD. RS means register select. RW means read or write. E means enabler. These are data pins. And LED plus LED minus means here in this LCD backside we kept the one LED inbuilt, and when we give the supply to the LED positive and LED negative, we can see clearly here what is printing on the LCD. Interrupts in microcontroller are hardware or software signals that temporarily suspended the normal program execution to handle critical events or external simulation. An internal or external requires to the MPU to stop the processing, which means interrupts are interrupts means it is a one kind of disturbance. It disturbs the program when it is going on in microcontroller. To to remove these interrupts, we use some methods, and due to this these are external interrupts and internal interrupts. External interrupts we cannot avoid. Internal interrupts means which are involved in the code or in software. Timers in microcontroller are versatile hardware modules used for measuring the time intervals, generating precise timing signals, and implementing time critical operations. Which means based on time which we are given, it will perform the activity. Which means when we give the 40 seconds for drying the clothes, it means it will take the 40 seconds exactly based on this timer. These timers are have some uh, types which are we can see here: counters, pulse width modulation, and capture or compare modes, ca- catering to a wide range of timing requirements. PW means pulse width modulation, which is operated by the pulse. Timers often features adjustable prescaler and reload values, allowing for grained control over the timing, resolution, and period. Essential for applications such as motor control, communication protocols, and real-time systems. Here we control the motor for to run in particular this time of period to dry or to wash the clothes in washing machine. Here we can see the project flow of project. First of all, we display the washing machine, and when we press the key 5, it will powering displays power on washing machine. Here we can see washing programs, and here, and then goes to water level. When we press it here on daily, long press the switch. When we long press the here water level, on water level screen any mode, it will shows the switch key screen. HW5 means start, HW6 switch 6 means stop. And when we press the switch 5, it will goes to the function screen. It will shows the time of to wash. 5 means switch 5 means start, switch 6 is used to pause. And after completion of the function, washing time, here 30 seconds is there, no, it will come to 0 seconds. It will shows the display door status display like this: doors open, please close. When we interrupt, when we open the door, it will close like this. And when the function is completed, then it jumps to the here program completion status. It will shows the output of the washing. Program completed, remove a class. That means take your class, the task is completed and washing is completed. Here we can see the washing machine project, and here is the code, header files, and this main files, and many more. We will take here new project, and then here we can select the micro chip embedded application projects. And next we can select the, here we can select the mid range, and here pick 16F877A microcontroller for our project as we are doing. And here we can select the XC8 compiler to perform these activities. And here we can give the project name, and we will finish this project. And here we can give the project code. Here we can build the washing machine project code, and it will give the hex file. I will show you here. You can see after building of this project, it is building. After building, it will shows build successful, and it will shows the path of the file where it will located. Here we can see .hex file. No, this is the hex file which we give in the pick 16A. Here we can see file and load hex file by the given path. No, in that path we can select this washing machine x dot production dot x. This means here I get this washing machine project hex file. I upload this one, and here we can see the display, and we will keep here clock pulse 20 for this one. And here we can select the display, and here we can see the boards. We are using Pick Genius board. Where is Pick Genius? Here we can select the Pick Genius, and here we can see the microcontrollers, number of microcontrollers. We are using Pick 16F877A microcontroller. No, that's why I am selecting here Pick 17 microcontroller, and here we can see this full one. Power on the washing machine program, and when we press on switch 5, it will enter. It shows the program powering on washing machine, and it is entered into the washing program. Here we can see the programs like daily, heavy, delicates, whites. When we press the switch 4, it will scroll. When we give long press, it will enter into the water level screen.
auto. Here we can see auto mode, low mode, medium, high, and when we long press on switch 4, it is entered into the window, another window, like press switch for switch 5 for start and switch 6 to stop. When we press the switch 6, it will coming back to the washing program screen, like I am showing now. When we press the switch 6, it is came back to washing program. Again, when we long press on the switch 4, it is entered into the water level screen, and when we long press on same switch, it is showing like press switch for switch 5 for start. When we press the switch 5, and it will entered into the here showing no times, we can select, we can give, and it is entered into the washing program screen. And here seconds, and that means time is given in code. And when the timer is start, and the fan will be rotated. When the doors are open, it will shows that doors are open, please close the door, and again it passes the function. When the timer will comes to 0, the fan will be stops the rotate, and we will listen the buzzer sound. After completion of washing, it will shows the washing completed, remove our clothes.